Hello everyone, welcome to the solution of LeetCode problem 133 named clone graph. In this problem, basically we are given the node reference of a connected undirected graph and we have to return the deep copy of this graph, which is the clone of the original graph. So this is the pretty straightforward problem statement. Now let's understand the algorithm in the next section with the suitable example. Now here, to understand the algorithm, we have taken this example. This is a basically undirected graph. Node 0 is connected to node 2 and 4. Node 2 is connected to 3 and 1. Node 3 is connected to 4 and 2. And node 4 is connected to 1 and 3. Now, we have to make a copy of this graph. So if it is the original graph, that means OR, the copy of the graph will look like the same, which is 1, 2, 4, and 3. Now the question is, why basically we use the graph copying? Basically, what is the application of this? Basically, the graph copying basically used in the such a scenarios that we want to do the debugging purpose. That means, suppose for this original graph, there are some of the problems and we have to resolve it. But while doing the conflict resolution or debugging, we have to make or alter this graph. So we have to change it. But if we make a deep copy of this graph, we can run the debugging process here. Now, similarly, if we want to run the parallel processing, suppose for this graph, we want to run DFS and the BFS at the same time. So it is optimal to run one algorithm in the original graph and the other algorithm in the clone graph. Now, it can be possible that we can apply the serializing. That means if we have to transfer this entire graph via network into some of the channel, so it is optimal for us to serialize the graph. So if we perform the serialization, the original graph will be changed, but it will be optimal that if we make a deep copy of the graph, we can perform the serialization into this copy graph. So these are the basically advantage of the graph copying or the clone graph. Now let's see how can we make the original clone of the graph. So here we have to choose a suitable data structure. So what basically we have to store? For each of the node, we have to store its neighbors. Now, so we have to store the value into a key value pair manner. So the map will be a suitable data structure here. In the map, the key will be the node and the value will be the node reference. So initially we will start the DFS from the node 1. So node 1 is not presented in the map. So we will make the entry of the node 1 and we will initialize a new node with the value of 1. Now from the node 1, we can go to the node 2 and node 4. Suppose we have gone to the node 2. So in the node 2, we have to check whether there is an entry presented in the map or not. Initially, there is no entry in the node 2. So we have to make an entry and add a new node named 2. Now from this 2, we have to move to the node 3 and node 2 again. Sorry, node 1 again. But node 1 is already presented in the map, so we don't have to do anything, or we have to simply return this entry node 1. After that, we have to go to the node 3 and make an entry of the node 3 So let's make an entry of the node 3 into the map. Now, from this node 3, we can go to the node 4 and node 2. But node 2 is presented here, so we have to return. Now, we have to add the entry of the node 4 and make a new node named or the value 4. Now from 4, we can get back to 1, and from 4, we can get back to 3. So both of the 1 and 3 is presented in the map, so we don't have to do anything here. Now after completing the DFS algorithm, we have seen that the final copies will look like something like this. The copies 1 will have the node reference 1 with the neighbor 2 and 4. Copies 2 will have the node reference 2 with the neighbor 1 and 3. Copies 3 will have the node reference of 3 with the neighbors 2 and 4. And the copies 4 will have the node reference of 4 with the neighbor 1 and 3. So this is how basically we will apply the graph cloning algorithm by using a map with the help of DFS algorithm. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named cloneGraph, which has a node as a parameter. Now, if the node is null, we have to simply return null. Otherwise, we have to check whether the current node is presented into this map or not. If the current node is not presented in the map, we have to make the shallow copy or the deep copy of the current node value and store it to the map. Now, we have to again iteratively do this process for each of the children. So, this loop basically iterates for each of the children of this node, and we have to recursively add the node reference to its neighbors, and we have to recursively call the clone graph function with the neighbors. Finally, we have to return the node reference of the current map. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.